Now in this third talk, let's look at some functions, recap some commands, and look at some mathematical arrays. Let's share the screen, come back to the source. Functions. As you might expect, LaTeX knows how to typeset a lot of mathematical functions. So that's great. Things like trigonometric and other elementary functions, exponential, logarithms, hyperbolic functions, so on. And so, examples are as follows. The classic identity, for example, the e to the I theta is cos theta plus I sine theta. You just typeset like that, using \x for the exponential, \cos for cosine, \sine for the sine. Then for hyperbolics, \sin h, cosh, and so on. For the logarithm, \log, and so on. It's all pretty natural. Now, one of the things to do is to admire the typesetting. Let's go to source. We had a look at spacing functions. Here we are. Exponential of I theta, we've got parentheses there, then we've got \cos theta. Note there's a nice, beautiful little space between the cos and the theta. This is good typesetting. We didn't specify it, we just said \cos. LaTeX knows what to do. Then we move to I sine theta. And we think, wow. And we have a look at the typeset. There's a little bit of a space before the sine and a little bit of a space after the sine. Again, this is correct typesetting. LaTeX knows it. The exponential doesn't have that spacing because LaTeX knows if you have x, sine, or cosine followed by a delimiter, it knows not to put a space there. This is great. You don't have to worry about it. Same over here for the hyperbolic, parenthesis log. There's no spaces around either side of that parenthesis because LaTeX knows not to put them there. Even though if it wasn't a delimiter, it would put a space. Now, there's some more complicated functions such as limit and max. Normally, when we put a sub or a superscript, it goes on the right-hand side of the symbol, yeah? But for limit and max and various other operations, we normally write information underneath lim and underneath max. LaTeX will do that for us. So this is the example down here. This is how we want it to be typeset. How do we get it? We say limit subscript q goes to infinity. LaTeX puts the subscript underneath. Is maximum over x, so \max, and then subscript x, and the x goes underneath. And LaTeX knows to do the same sort of thing with large operators, such as the sum. It's fairly poorly typeset here, so let's go to tech. Yeah, where's the sum? Yeah. So e to the x is the sum n equals 0 to infinity. X to the n over n factorial. So n is equal to 0 is the subscript of the command sum. Note that's not Greek capital sigma, it's a sum. It's a slightly different symbol. Some subscript, and then the infinity is the superscript. Where n factorial is the product from I equals 1 to n of I. And again, product is subscript, I is equal to 1, superscript, n. Similar for intersection, which is here, big cap, subscript alpha. Okay, now, that's not the end of the story, because LaTeX is sufficiently astute to know that when you typeset that sort of thing in inline mathematics, which we've got here, so here's a sum from n equals 0 to infinity, it knows not to put the n is equal to 0 underneath the sum. And the infinity doesn't go above the sum. For inline, just a sec. There we go. Short interlude from my dog. So LaTeX knows to put it to the side for inline text. So let it do its job, because that is correct. Some people go to great lengths to force LaTeX to do it wrongly and not right in line. Don't do that. No, did the wrong one. Okay, so what about command definitions? Yeah, actually, there's, yes. Okay, so we've commented that LaTeX provides a facility to define your own commands. So what happens if it doesn't have a function that you want? There is a finite limit to what it knows. So the airy function is symbolized in mathematics by AI. So you just use a function command to define it. New command \AI, and then you define it to be AI. But importantly, make it an operator by saying \operator name AI. Right? And then we can use the command \AI wherever it's needed. And the reason for defining it to be an operator name AI is because then LaTeX knows to treat it as a function name, like sine, cosine, exponential, log, and so on. So you get all of that benefit of what LaTeX knows about a function. So here, for example, if you say \AI x is equal to the integral, LaTeX will put a little bit of space there. Do this wherever you need a 2 or 3 letter mathematical constant or function, or 4 letter. So it's not just functions, also the constants. And the reason is that multi-character mathematics symbols must be in upright Roman font. Go back to text, have a look at sine, cosine, exponential, sin h, log x. In all good textbooks, mathematical functions are in upright Roman font, not the italic. This is the standard, this is what you must do. And the reason is it's a multi-character symbol. The standard is multi-character symbols in maths are upright. So things such as Reynolds number, RE, need to be typeset in an upright font, RE. Prandtl number, PR, upright font, PR. Peclet number, PE, upright Roman font, PE. And you get it using operator name. And the easiest way to get it consistently is by a new command. Very few people do this. It's such a pain. Now, I've discussed some of these other commands before. I won't do it any further now. These are some of my favorites because they just save me so much time. You know, they give us either a new facility, new logical structure, or they allow us to redefine the physical appearance of the correct logical expression. But you can also create commands one higher level of abstraction. You can create commands that create commands. The more mathematically inclined of you will appreciate that facility. So here's the sort of thing you can do. I'll just point you in the direction. I won't explain it all. If we want a command that allows us to easily define commands \cc, \nn, and \rr to consistently generate the bold-face C, N, and R for complex numbers, natural numbers, real numbers, and whatever else we might like using blackboard bold font. We can generate the commands that generate. We can define a function that generates these for us to later use. Right? And here it is in action, \bbc, \bbn, \bbr, defines these to be those via defining \bb to be this. It's, like I said, high level of abstraction. Yeah, and what you do, so \bbc, it's a command with one argument. We give it a capital C. And then there's some mysterious stuff here. Expand after, what this, that. I'm not going to tell you. CS name, #1, that puts two C's here. And the CS name and the NCS name says the two C's are the form A, LaTeX symbol, \cc. A cunning thing, that. And then the def says define \cc to resolve towards this. And sitting at the heart of that is the blackboard bold C. So that's commands at one higher level of abstraction. And you can keep going, actually. But it gets pretty twisty. All right, what else are we going to look at? Arrays. Now, frequently we have to typeset mathematics in tabular format. It's pretty much the same as the tabular format for tables. The usual reason is to typeset in a matrix. So AMS Math provides us with some convenient matrix commands. So begin B matrix, end B matrix, typesets a bracketed matrix. And just as for the tabular environment, each row is delimited by a double backslash, and this has got 3 rows. And then each column is delimited by an ampersand, so this matrix has got 4 columns, 3 rows, and the 3 dots there represent whatever stuff we want to appear in the matrix. Where is it? Heck. No, just done that. Oh, here's our matrices. Yeah, so this first equation, we've got 3 matrices. The first one is 2 rows and 3 columns. That's that code. The second one is 1 column, 3 rows. That's that code. And the right-hand side is 1 column, 2 rows, and it's that code. And you can see, yeah, let's go back to the source code. Brackets. AMS Math has got a command matrix, which does the array, but without the brackets. You've got P matrix for the array surrounded by parentheses. Then, particularly useful is the cases environment. Puts a brace on the left side and no delimiter on the right, and it's designed for mathematical case statements, as in the tech here. So, for example, over in the tech, we've got mod x is equal to x if x is bigger than or equal to 0, minus x if x is less than 0. It's a case statement, so we want a brace on the left and nothing on the right, and you get that with cases. The simplest way to do it. The if command, typeset it with \text if blank, end of brace. so that there's a space between the if and the mathematical else. Okay, and then you can see in this example that sometimes when you typeset matrices, we want dots all over the matrix, horizontal, diagonal. LaTeX has a lot of dots. So the horizontal ones here are \C dots. Diagonal ones are \D dots for diagonal. And the vertical ones are \V dots for vertical. But there's more. It's not just that. What else we got? There's a bit of subtlety here. C dots typesets 3 dots horizontally at the height of the center of a plus sign, so it's centered in the line. And these dots are called ellipses, by the way. Such dots. And you need to learn them because there is also \L dots, which is a row of 3 dots horizontally, but they are at the height of a comma. And you can use L dots outside mathematics as well. So which one of C out of N or L should you use? And the answer is you use the ellipsis that matches the height of the operator that you are extending. If you've got a comma-separated list, use L dots. If you're in the middle of a sum, plus minus, then the mathematical operator is sort of centered vertically, so you need C dots. Yeah, don't just typeset 3 full stops to get an ellipsis. It's just horrible. Spacing all wrong. Okay, then as mentioned, V dots for vertical, D dots for diagonal. You can embed arrays within arrays, whatever you need. Sometimes you need to do that. The AMS matrix environment is the most common one that you'll need. Sometimes it's not quite flexible enough, in which case use the array environment, which is the same as the tabular environment, but it's for mathematics. And you put in column specifiers, C, L, whatever. And right. So we take a break there before we get on to our last